What's the best about painting with today? 2014, number one, experimental design and data analysis. Trichomes are hair-like outgrowths of the epidermis of plants that are thought to provide protection against being eaten by herbivores. In a certain plant species, stem trichome density is genetically determined. To investigate variation in stem trichome density within the plant species, a student counted the number of trichomes on the stems of 6 different plants in each of 3 different populations. The student used the data to calculate the mean trichome density, number of hairs per square centimeter, for each population. The results are provided in the table below. So here I see my population 1, and I can see the 6 different plants plus the mean and the standard error of the mean, and you can see that for all 3 populations. So on the axis provided, create a appropriately labeled graph to illustrate the sample means of the 3 populations to within 95% confidence, i.e. sample mean plus or minus 2 SEM. Okay, so because of the fact that my data is categorical, I know this is going to be a bar graph. So I'm going to label my x-axis. I've got my 1, 2, and 3 populations, and I'm going to label my y-axis, the mean trichome density, which the units will be the number of trichomes per centimeters cubed. I also want to make sure that I have scaled my axis. So I'm choosing to make each block 1, but I'm only going to label every other one. So you can see I'm counting by 2s. When you're creating your graph, always make sure that you have a number that is easy for you to count by, and you're taking up as much room on the graph as you possibly can to ensure that the reader can differentiate the points that you are graphing. So I'm going to graph population 1, which has a mean of 9, and then I'm going to do my standard error of the mean. Now, according to the prompt, it told me I'm doing plus 2 standard errors of the mean, and then also minus 2 standard errors of the mean. So I'm going to go above and below by 2, because my SEM was 1, and 1 times 2 is 2, so I'll go 2 up and 2 down. I then need to graph my population 2, so 11. Again, same thing with my standard error of the mean. And then I'm going to graph population 3, which is 14, 2 standard errors of the mean above and below. So the points were given for this for having it correctly labeled, scaled with proper units, a bar graph or a modified bar graph. And I'll show you a modified bar graph when we see the student's response later. And then 2 times standard error of the mean above and below the mean. So here we see that modified bar graph. So when they do a modified bar, they just put a data point at where the mean is, and then they would extend out the 2 standard errors of the mean from that. And the student has received all 3 points for this one. So part B is based on the sample means and the standard errors of the means. Identify 2 populations that are most likely to be statistically significant in the mean stem trichome densities. And we want to justify that response. So if we look here at population 1, I see that population 1's error bar overlaps with population 2, but does not overlap with 3. We would then compare number 2. 2 overlaps with both 1 and 3, and then 3 overlaps with 2. So I can say that the 2 that are statistically significant would be 1 and 3 because their error bars do not overlap. So the standard errors of the means do not overlap between population 1 and population 3. So here we see our identification of populations 1 and 3. We can see the justification is the error bars, 95% confidence intervals for population 1 and 3 do not overlap. Whenever you have a question like this and it's asking you about justifying that, and you're using the error bars, don't just say they overlap. Be sure that you designate which error bars are overlapping so that the readers know that you are looking at the same data that they're looking at to come up with what was statistically significant. So students said plant population 1 is most likely to have statistically difference in mean stem trichome density for population 3 because the means as well as the standard error of the mean do not overlap numerically. There is a difference of 1 between the highest limit of population 1 at 11 and the lowest of population 3 at 12. This means the data within those data sets cannot equal each other. Data in the other set and remain acceptable. So data in those sets. I'm sorry about that handwriting. So part C, describe the independent and dependent variables and a control treatment for an experiment to test the hypothesis that higher trichome densities in plants is selected for in the presence of herbivores. Identify an appropriate duration of the experiment to ensure that natural selection is measured and predict the experimental results that would support the hypothesis. Whew, that's a lot of stuff we got to do. Okay. So if I'm looking at my experiment and I'm trying to test about having higher trichomes in the presence of herbivores, then my independent variable is going to be what I'm changing. I'm changing those herbivores. I'm testing to see if herbivores have an effect. So my independent variable will be herbivores. My dependent variable is going to be the number of trichomes on that plant. So looking at the density on those plants. I then need to come up with a duration. I want this to take place over a certain amount of time. I want to come up with more than one population or more than one generation, because I want to be able to see natural selection taking place. So I need to see it over multiple generations. And I would predict that the experimental results that would support that hypothesis would be that there would be a higher number of trichome in the experimental treatment than the control treatment. Ooh, and I never mentioned the control. The control treatment would be if there's no herbivores. So if I'm testing to see if the presence of herbivores have an effect, then I want to see what no herbivores. So I'll be able to compare them to see, does the herbivore actually have an effect? That's the whole point of a control, is to see if your independent variables actually have an effect. So here we can see the data table showing us that we get a point for presence of herbivores for independent, trichome density for dependent, absence of predators for our control, more than one generation for duration, and then our prediction being increased trichome density relative to the control. Now they had another option they could have put, where trichome density in the presence of herbivores was your independent, reproductive success or the number of plants being dependent, the control being plants with lower density, more than one generation, and then some of the population with hires will have density will be larger than the population for control. So students said, in an experiment to test for whether higher trichome density is selected for in the presence of herbivores, the independent variable would be exposure to herbivores. The dependent variable would be the number of trichomes per centimeter squared, and the control would be population of plants that is not exposed to herbivores. An appropriate duration would be over several generations, let us say 7, to test the offspring of the gametes, begin to show the phenotype that is being selected for in a measurable percentage that can be compared to the change of the control. This change will occur if natural selection changes the frequency of phenotypes. I predict that the mean in SEM will be higher in the plant population that is exposed to herbivores than in the population without exposure to herbivores. I hope that was helpful. Remember, APY pain was just success. And now that I'm thinking about it, I may have made an error in that graph where my units were cubed instead of squared. So I'm sorry about that error. But remember, APY pain was just success. Bye, y'all.